Hello and welcome to the Medicaps Learning Series. I am Dr. Anjali Soni, Head of the Chemistry Department, Medicaps University, and today we will explore about the rate of reaction. Today we are going to learn about the rate of reactions. So what is the rate of reactions? The content we will discuss about these topics today. We will discuss about the definition and the types of the rate of reaction. We will discuss about the unit of the reactions with examples also, and the graphical representation of the rate of reaction and some factors affecting the rate of reaction. This is the content of the rate of reaction topic. So starting with the first point, that is about the definition of the rate of reaction, how it is defined. First of all, you should know about what is reaction in chemistry. So reaction is that when reactant is converted into the product, that is known as the rate of reaction. Starting with what is the definition of rate of reaction? So what is the change in the concentration of reactant or product with respect to the time? That is, you can define as you can represent as change in concentration of reactant or product with respect to the change in time. So this is the expression for the rate of reaction. It is unit is that mole per liter per time, because if the concentration is expressed in the unit mole per liter, then change in time is expressed in the time. So rate of unit is the mole per liter per time. Consider first example. We can see some examples also. Here is the example of this reaction. Mercury plus chlorine, it will give the HgCl. In this reaction, these are the products, these are the reactants, and this is the product. So consider this one. This is the reaction in liquid phase, gas phase, and it is the final product. So how it is represented with the help of the rate of reaction? We can represent as this is the reactant, this is the reactant, and this is the product. So in terms of the reactant and the product, as we know that in the reaction, change in the concentration, that is the rate of reaction is that change in the concentration of reactant or product. In a particular chemical reaction, there is a decrease in the concentration of reactant and increase in the concentration of product. So we can write here as the minus sign, why minus sign is here? Because here decrease in the concentration of the mercury, that is here it is the reactant. So change in the concentration, that is minus sign indicate the decrease in the concentration of reactant with respect to the time. Then consider next is the decrease in the concentration of the chlorine with respect to the time. That is, so why minus sign here? Because minus sign is here because of the change in the concentration of the reactants. Again you can see here, now these two reactants are reacting and giving the product, that is the HgCl2. HgCl2 is the product here. So we can write here the delta HgCl2 divided by the delta T. Square sign represent the square sign here represent the concentration of the reactant as well as the concentration of the product. So again we can consider the second example. Here the second example, that is 2Hi. This is our reactant. It is dissociated into the product, that is H2H plus I2. Mercury H2 hydrogen plus I2. We can see here how can we write the rate of reaction in terms of the formula. That is the rate of reaction is equals to minus half. Why minus half is there? Because it is a reactant and the concentration is here 2. So we have to divide it by 1 by 2 delta Hi by delta T, and it is equals to minus del H2 upon delta T. Consider the second example to express the rate of reaction. This is the reaction 2Hi. It is converting into the H2 plus I2 in gas phase. So how can we write the rate of reaction? So this is the expression for the reaction. How can we write the rate of reaction in terms of the presentation? Rate of reaction is equals to minus half. Why minus half? Because here it is the 2Hi. So we have to write the 1 by 2. Minus sign is where? Minus sign is why? Because minus indicates about the reactants. Now it is minus half delta Hi upon delta T. Then it is equals to H2, that is hydrogen is our product. So H2 divided by delta T, it is equals to delta I2 upon delta T. So this is the second example. In this way rate of reaction can be expressed. So more examples can be considered. So now next topic is about the types of the rate of reaction. So there are generally two types of the rate of reaction. First is the average rate of reaction and second is about the instantaneous rate of reaction. What is average and the instantaneous rate of reaction? That is, average is that overall change in the concentration of reactant or product over a longer period of time is known as the average rate of reaction. Second is about that instantaneous rate of reaction, that is at a specific point or time the change in the concentration of reactant or product is known as the instantaneous rate of reaction. Other than these two types, there are again three types of the rate of reaction on the basis of the speed, that is fast reactions, moderate reaction and the slow reaction. What are the fast reaction? Which are completed within a few seconds, within a minutes. These are known as the fast reactions. For example, explosion of the sodium in water. This is the example of the fast reaction. Next is about the moderate reaction. Moderate means it will take some time. That example, best example of the moderate reaction is that photosynthesis reaction. Second is third one is about the slow reaction. Slow reaction means it takes longer time for the completion of the reaction. So, after the example of that fossil fuel formation. Next is about the, we will proceed next is about the graphical representation of the rate of reaction. How can we represent the rate of reaction in a graphical way? This is the example, this is the representation of the graphical representation of rate of reaction. That is, we can plot the rate of reaction as x-axis time, y-axis concentration of reactants. It is expressed in the mole per liter. This is the graphical representation of the reactants, because concentration of the reactant is decreasing continuously. As you can see here, as the time increases, concentration of the reactant decreases. So, this is the example of the rate of reaction in terms of the concentration of reactants. Next is about the concentration of product. This is the representation of the concentration of product versus time. As the time increases, the rate of concentration of products increases. So, here you can see that you can differentiate between this is expressing about the rate of reaction for the reactants, this is expressing about the rate of reaction for the products. Now, the factors affecting the rate of reaction. There are so many factors which can affect the rate of reaction, such as first is the concentration, then temperature, surface area, catalyst, nature of reactant and physical state and the pressure. First of all, concentration. So, what do you think? As the concentration of reactant increases, the rate of reaction increases. Next factor is the temperature. As the temperature increases, rate of reaction also increases. Why it increases? Because on increasing the temperature, the kinetic energy of the molecules increases. So, that is why rate of reaction increases. Next, third factor is the surface area. Especially in the case of the solid substances, solid reactants, as the surface area increases, the rate of absorption increases, so that is why rate of reaction increases. Now, fourth factor is the catalyst. As you know that catalysts are the substance which can alter the rate of reaction. There are two types of the catalyst, positive catalyst and the negative catalyst. Positive catalyst can enhance the rate of reaction and the negative catalyst can inhibit the rate of reaction. So, it depends on the catalyst. So, catalyst can alter the rate of reaction. Now, fifth factor is the nature of reactant. Nature of reactant means it depends on the solid reactants, liquid reactants and the gaseous reactant. So, think for that in case of the gases, reaction rate is faster because gaseous molecules can move fastly. So, as compared to solid, liquid and gases, reaction rate is faster in the gas molecules, then it is slower in the liquid molecules and then slower in the solid molecules. Then comes the physical state, again solid, liquid and gaseous state is there. Then about the pressure. Pressure is that on increasing the pressure, the rate of reaction increases, especially in terms of the gaseous molecules. As the pressure increases, gaseous molecules comes closer and that is why concentration increases in gaseous molecules, and about that, in that case rate of reaction increases. So, today we already discussed about the rate of reaction. Just summarize what we discussed today. So, we discussed about the rate of reaction, that is what is the rate of reaction. Then we discuss about the what are the types of the rate of reaction. Then about the unit of the rate of reaction with some examples also. It is expressed as the change in concentration change in concentration of reactant or products with respect to time. And the unit is a mole per liter per time. Then we discuss about the graphical representation of the rate of reaction, and finally and lastly we discuss about the factors affecting the rate of reaction. Today's session on the rate of reaction. Stay tuned for the more PCM basic